Hi everyone, let's solve this problem counting bits. Given an integer n, return an array answer of length n plus 1 such that for each I lies between 0 and n. Answer of I is the number of ones in the binary representation of I. So let's understand how we write our binary representations, and then we will see how many ones are there in each representation, and we kind of return the array of number of ones in each number from 0 till n. So for this, let's take an example of n is equals to 5. If n is equals to 5, we will have 1, 2, 3, 4 and 5. Now let's take an example. Initially all of them counts will be 0, and then let's take binary representation. Binary representation we can go till 32 bits, but for simplicity let's use only 4 bits for understanding purpose. Let's take 3 as the number, so 3 will be 0 1 1. So this will be the representation, binary representation of 3. There will be more bits in the front, but we can ignore that for now. So we will do AND operation with 1 initially. So this is 1 0 0 0. This is not equal to 0, so we will increment our count by 1. Then we will move our bit forward 0. In that case, what will happen is, if we perform AND, 1 and 0 will be 0, 1 and 1 will be 1. So this is also not equal to 0, the count will be 2. And I'll move my bit forward, and this will be all zeros. So this is equal to 0. We don't increment our count. And then again we move 1 to the left, so it will be 1 0 0 0, and all of them will be 0, so we don't increment our count. Similarly, how we are doing for 3, we are going to do it for other numbers as well. Let's take one more example for better understanding. And once we get the count, in this case we got count as 2, right? So we will update our count. Let's take an example of 4. Binary representation is this, and first initially we'll do AND with 1. So it will be 0 0 0 0. So we will not increment our count, it will be 0. And then we will move our bit forward 1 and 0. So this is still 0, we will not increment anything. And then it will be 1 0 0, it will be 1. So now this is not equal to 0, so we can increment our count 1. And then I will move it even further, so it will be 1 here. So this will again be all zeros. It is equal to 0 now, so we don't increment our count. So overall we found number of ones in the binary representation of 4 is 1. So let's try to code it up. We have just seen for 2 examples, but we will be doing it for all the numbers, and we'll be storing. So result initially will be empty array, then we will be returning the result array. We are iterating over all the numbers till n I plus plus. Now we will have a count variable which is initialized to 0, and we will be moving from 0th bit till bit less than 32 bit plus plus, and we are going to check if the number, and if we are shifting that number by the bit position, if it's not equal to 0, that means we have a 1 representation in somewhere in the binary number which we have taken, so we will increment the count. And we are going to push the count into the respective index, nothing but 0 1 2 3 4 5. So that is done. Now let's try to run it. It works fine. Let's submit it. It submitted successfully. Now let's also understand the time and space complexity. Time complexity is big of n into 32, because this operation takes n time, and this is 32 operations, which is constant. we can ignore that, and this operation is again big O of 1. So overall it will be big O of n, and the space complexity would be big O of n. This is for the result where we are storing the n number result. I hope the solution is clear. Thank you.